So, maybe before we try to draw the block diagram for each of these subsystems, what we will do is try to draw the block diagram of the entire product, and then from there lead our way into every subsystem. And it's good to do this exercise because it gives you a sense of what block is talking to what other block, right. So, now in that spirit, let us look at the maybe a block diagram or a block diagram of a Bluetooth headset. So, at the center of all of this will be a microcontroller, or what you will call an MCU. So, there is a microcontroller. Now, this microcontroller is going to talk to the connectivity subsystem. So, it is going to tell the connectivity subsystem that, oh, okay, you have packets to give me, okay, give it to me, I have packets to transmit, go transmit that. So, somewhere here there is some sort of an interface that allows the microcontroller to exchange information with the connectivity subsystem. And once the microcontroller exchanges information with that connectivity subsystem, it is going to tell the audio system either go play this or give me what the user said. So, there is an audio subsystem that again exchanges information with the microcontroller. Now, it might so happen that part of that audio subsystem is implemented in the microcontroller, and it is also possible that you can find one chip that has both the connectivity and the audio subsystem and also has the MCU. So, it is not necessary that each of these has to be individual chips, they can be individual chips, but it is also possible that it is all integrated into a single SoC, a single system on chip. So, for the purposes of block diagram, we will assume they are separate, and we will see how to bring them together. So, the connectivity subsystem and the audio subsystem exchange information through the MCU. And now the MCU might also say, okay, I know what state we are in, I know what is happening. So, it is best that I maybe through the GPIOs I have or the general purpose IOs that I have drive the LED subsystem. So, we have the LED subsystem here, and these might have, let us say I have an RGB LED, these might have 3 GPIOs on the microcontroller that then go connect to the LED subsystem. From the MCU to the LED subsystem, it is sort of one directional. There is really, in most cases, there is very little feedback going from the LED subsystem to the MCU. The MCU just drives that IO. You can think of the IO as a switch. It either pulls it up or down or closes or opens the switch, and that switch decides, opening or closing the switch decides whether that particular light comes on or not. So, this is let us say a tricolor RGB LED, right. So, that is how the MCU talks to the LED subsystem. Now, as this diagram unfolds, you can see that, okay, the microcontroller is sort of the master, the central intelligence unit that understands everything or that has awareness of what each of these subsystems is doing. So, it goes on to follow that, oh, if I have a sensor subsystem, that sensor subsystem should also connect to the microcontroller. So, if I have a sensor subsystem, let us say I have IR sensors or I have pressure sensors, temperature sensors, whatever I think is worthy of being sensed for my product, that will now again talk to the microcontroller. Now, it can so happen that the sensor subsystem itself comes with the blocks that provide digital data, or the digitization might happen in the microcontroller. Right, that maybe we will not get into it at too much detail, but the idea is that now there is the MCU that understands the different states. Now, each of these blocks or each of these subsystems connect into the MCUs. With the case of connectivity and audio subsystem, that interface will be digital. With the LED subsystem, that interface is an IO interface. With the sensor subsystem, that interface can be analog or digital. And then we talked about the fact that these are active circuits. That these are active circuits means that they have they need to get power, and that power itself is provided by the power management subsystem. So, it is the power management subsystem that now gives power to this block, that gives power to this block, gives maybe power to this block, gives power to this block, and gives power to this block, right. Maybe let me just make some space for something else I want to put here. So, this we will go this way. So, this is the power management subsystem that is delivering power to each of the systems, that is helping the system deliver whatever features that you want from it. So, whether it be connectivity, audio, the microcontroller, the sensor or the LED subsystems, they are all going to draw power from the power management subsystem. There is still one piece missing, which is the charging subsystem. I mean, you have a portable device, you have a rechargeable battery. That battery is charged by the charging subsystem. Now, the charging subsystem is going to provide the, or maybe let us not do it this way. So, the power management subsystem operates from the battery. So, it has the two terminals of the battery connected to it, and the charging subsystem will connect to the battery because it is the battery that it is charging, and it will also have ports for V bus and ground. So, if now through wall power supply, so this will go either to a wall power supply or a power bank or whatever other means that you have to charge the device, right. So, the charging subsystem is one side of the charging subsystem are the battery terminals, the other side of the charging subsystem are V bus and ground. So, this now is our block diagram. So, again, not super thorough, not super complete, but it gives us an idea of, okay, these are the systems, these systems have to talk to each other, right. It also gives us a comprehension of, for us to put this system together, what are the different capabilities that need to be integrated, right. So, when we talk about and that is the next thing we are going to do, and we are going to do that by working through maybe slightly next level block diagrams of these subsystems, and at that point maybe we will start demarcating boundaries between the digital and the analog subsystem, right. But it is again interesting to think about, and maybe I am laboring this point a little bit, but I think it is worth laboring, the importance of understanding that, oh, even a conceptually simple product has a number of complex subsystems that come together. So, it is important as a follow on to be able to draw distinction between where should we apply our intelligence, our knowledge for product experience. Is it in building these subsystems? Is it in understanding how the subsystems are built, having a working knowledge of those subsystems, not building it themselves, not building it ourselves, but having a working knowledge of these subsystems, and then focusing on the integration and some specific aspects of the experience we want to deliver. Now, as a system becomes more and more complex, it becomes harder and harder to do everything from scratch. It will take forever to do it, and the resources will just untenable to really go down the path of building that product. So, it is important for the engineer who is putting the system together, who is architecting the system, to start to make some judicious choices with respect to, okay, what am I going to build, what am I going to use, how do I validate that what I am using is the right thing to use, right? Because the end consumer really is not worried about whether I use this chip or that chip or some other chip. The end user has no visibility into that. The end user is trusting the embedded system engineer to make that call for him, to make that call saying, okay, you know, this is the experience, maybe I want to do spatial audio. If I want to do spatial audio, this is the amount of resources I need to be able to implement the spatial audio transfer functions. That has an impact on the clock frequency and hence the MIPS, the RAM and the flash, which is the amount of memory you might need, that I need of the microcontroller. So, now it is up to the embedded engineer to take a feature of this form, break that feature down into what does it mean in terms of the capabilities that these individual blocks need to have, and then what is the most judicious choice of where I should take the block from, right. So, that is sort of what we are trying to lead this conversation towards. As a next step, what we will do is map out these block diagrams, and as we map out these block diagrams, let us start to maybe get into one more level of detail in seeing, okay, where is the boundary between analog and digital, which subsystems are 100% analog subsystems, and do such examples exist here. Are there some subsystems which are maybe mixed signal, and what is then the analog portion in that subsystem. So, that is what we will try and look at next.